Okay, we'll finish up our chapter 5 PowerPoint. So section 5.4 is just looking at, because lipids don't like water, how then do we transport them through the bloodstream? So the way essentially that they go through is they use what are referred to as lipoproteins. So this is just a transport vehicle for lipids because, again, water and oil don't mix. So how do we get them through there? So essentially the very inside of them is lipid, and then the outer shell is protein, has some phospholipids and cholesterol that water can interact with. So essentially just kind of packing and hiding those lipids in the inside of proteins. So what they look like here, again, all of the lipids packed in here in the middle because they don't like water, so essentially just going to hide them. And then we add these proteins on the outside, and then we add this kind of layer of a phospholipid. Again, the outer part of the phospholipid, where that phosphate group is, it likes water. So we're essentially just hiding those molecules that don't like water inside of this little packet. Chylomicrons are the name for those molecules that are transporting them. So what happens is in the small intestine, the fatty acids are reformed into triglycerides, and then they're packaged into the chylomicron. So we kind of looked at that before. So the lipase breaks everything apart. The fatty acids and the glycerol get absorbed into the cell, and then they're put back into a triglyceride. Once they're put back into the triglyceride, the chylomicron is going to surround them and acts as that transport vehicle. And most of those fats are absorbed then into the lymphatic system because, again, they're too big, and then ultimately that empties into the bloodstream. And then once in there, there's what's referred to as the lipoprotein lipase. So that's the enzyme then that breaks down the triglycerides that are inside of that lipoprotein. All right, now there are some different types of lipoproteins. So there's low density, or LDL. This is referred to as bad cholesterol. It starts out in the liver, and essentially what it does are these LDLs are taken up by these scavenger cells or white blood cells, part of our immune system, and it actually forms these plaques on the inside of blood vessels, and that ultimately builds up, and it can lead to heart disease and high blood pressure. So again, this is kind of the primary risk of having too many LDLs is that atherosclerosis, again, these plaques on our blood vessels, and increases the risk of cardiovascular disease. Now, HDL, high density lipoprotein, it actually removes the cholesterol from the blood, and this is referred to as good cholesterol. So the LDLs store it in the blood vessels. The HDLs get rid of the cholesterol. It also originates in the liver, but again, it's scavenging for that cholesterol that's in the blood vessels to transfer it to the lipoprotein or to the liver. So again, it's taking it away from the bloodstream, not into it or storing it there. So actually we want to have high amounts of LDL. So it helps block the oxidation of that LDL that forms the plaques. It reduces plaque formation and reduces the risk of cardiovascular disease. This is just showing the different types of these lipoproteins. So again, we have the chylomicron that's mainly carrying the triglycerides. So it's carrying those fats from the small intestine. We have VLDL, which is very low density lipoprotein. Again, it carries the lipids that are in there and that are taken up by the liver and takes them to the cells. So it's carrying triglycerides. The LDL has, again, that cholesterol in it. And it, unfortunately, though, is taking that cholesterol and it's storing it there in the bloodstream. Whereas our HDLs that have a lot of proteins, it's going to help remove the cholesterol from the cells and get it out of the body. All right, so why do we need lipids? What are their roles? So obviously they provide energy for us, that 9 kilocalories per gram, but also a lot of structural components in every cell. So especially the phospholipids that make the membrane, cholesterol helps make the membrane, and the fatty acids can also help just regulate cellular processes where we think about the sterols that help make other hormones that we need for the endocrine system. All right, as far as providing energy, so that fatty acid, so once it's released, it's an important fuel source, so it can be broken down. And the breakdown of those fatty acids releases a lot of ATP, that energy source. And actually about half of the energy used at rest during kind of light activity, it actually comes from our fats. So just kind of sitting around, not doing a whole lot. Light energy, we kind of use a lot of those fatty acids. The remainder, though, is derived from those carbohydrates. Right. So as far as storing them for later, again, triglycerides are the main long-term energy storage for our cells because, again, it yields so much more energy per gram than what the carbs or the proteins do. So the ability to store fat, though, is limitless. Unfortunately, it would be nice if there was a limit and our bodies would just stop. But we keep storing it. If we have it, we just keep adding on and adding on, which of course leads to obesity. Where it's stored are in what are called adipose cells, and they can actually increase about 50 times their actual weight by adding those triglycerides in there. So again, we have this limitless ability just to store fat. So again, if that amount of fat that's stored exceeds the ability, then the body just makes more cells. So even if they're packed full, then it just says, oh, hey, we need to make some more. So we keep making more and more adipose cells to store that. And those adipose cells contain about 80% lipid, only about 20% water. So that's really their only job. They're not like breaking down stuff for energy. Their main job is to store those triglycerides. All right, another function of those is to help insulate. So we think about like our polar bears or animals that are hibernating, they store up a lot of fat in there, as well as just cushioning or protecting the body. There's always a layer of fat right below the skin to help insulate us. Again, it's that adipose tissue, not a lot of water in it, so it doesn't conduct heat very well, so the heat stays inside. It's like a nice little blanket around our cells, so it slows that heat loss from the body. Right. Then also we have fat tissue not only just under the skin, but also around some organs, and that just protects them, provides a little cushion layer to prevent any type of injury. Right, now, as far as digestion, absorption, and nutrient transport, so again, cholesterol here, that's actually needed because it helps make our bile acids that then help break down other fats. Those bile acids and phospholipids, again, they can be emulsifiers, which help dissolve the fat so that it can be transported through the blood or through those watery areas. So again, it suspends them into water. It also helps break apart large droplets of fat into smaller ones so that those enzymes can break them down a little bit better. Again, our phospholipids are necessary to transport those lipid-soluble materials. So again, thinking about the outer shell where we have a lot of those phospholipids, and then inside we store all the lipids that don't like water. So again, that outer shell of the lipoproteins. So these lipids in food also help carry fat-soluble vitamins. So not all vitamins like water. So the fat in there helps store in and transport those vitamins. As far as body structures, so again, the cell membrane, as I mentioned a few times, again, those phospholipids are what form the bilayer to make the cell membrane that all cells have. The water-soluble phosphate heads, they like water, but then the fat-soluble fatty acids don't. So it creates this barrier there. And then cholesterol, again, gets added to kind of stabilize the membrane. Now in the nervous system, actually lipids make up about 60% of our brain. So there are a lot of lipids in the brain. Again, remember the slide about the beef brain having so much cholesterol in it. That's because that's a lot of the lipids actually get stored in the brain. So there are phospholipids and cholesterol because not only do they make the cell membrane, but around all of the nerve cells, there's this kind of insulator called myelin. So just like an electrical wire, the insulation around it helps increase its ability to conduct nerve impulses or electrical impulses. Our neurons have this myelin coating made up of fats that act like that insulator to improve conduction. All right, and this is just showing that lipid bilayer. So again, we have these two layers of phospholipids, one outside and one inside. Each of them, though, has this head region shown here in pink. That's where that phosphate group is that likes water, and then those two fatty acid tails that don't like water. So it creates this barrier where things really can't cross unless they're like small fatty acids. So it really helps regulate what's coming in and out. And we also see our little cholesterol here to kind of stabilize those fatty acids. All right, as far as its role is regulating and communicating, they are important regulators of chemical processing, so just messengers to communicate with other cells. Besides cholesterol, other sterols are used to make hormones, so like estrogen and testosterone, even vitamin D. We need those sterols for that. Again, those essential omega-3 and 6 fatty acids, they're needed to make other fatty acids, and those eicosanoids, which are chemical messengers, especially like with inflammation or pain or immune function, they're needed to make those messengers. All right, as far as our recommendations for how much fat to intake, as far as the total amount of fat, there's really no recommended daily allowance for that. Some kind of acceptable distributions. So somewhere between 20 and 35% of our kilocalories should come from fat. So it's not like you have to consume so many grams of it. It's just as you're consuming your diet, about, a third or so, a little less than that. A fourth to a third should be from fats. So that converts to about 44 to 78 grams if you're consuming 2,000 kilocalories. Now, as far as saturated fatty acids, again, we want to stay away from those. So instead of having an RDA, we really want to limit those to less than 10%. So again, we want to have about 20 to 30, but of that, only 10 or even less should be saturated. So the American Heart Association recommends only 5 to 6 for those at risk of cardiovascular disease, just to help prevent issues. And then the typical intake is about 12% of total calories. So again, trying to decrease that to less than 10 is a goal. All right, so if we look at those essential fatty acids, so the omega-6, men should take in about 17 grams a day, women about 10 or about 12. And then we don't need quite as much as the omega-3, only about 1.6 for men and 1.1 for females. But again, if we fail to consume enough of those, then that's whenever those deficiencies. Because again, if something is essential, it means if we don't have it, we start to see negative effects. So this can involve kind of a rapid turnover of epithelial cells, so like our skin fluffing off. So flaky, itchy skin, wounds aren't going to heal quite as well. Even diarrhea can occur from that, hair falling out, vulnerable to infections because we don't have those eicosanoids to help with our immune system, and even impairing growth in kids. Right, as far as cholesterol, again, there's no specific limits on dietary cholesterol, but we do want to, or it's been shown that has a little impact, the dietary cholesterol has little impact on the blood cholesterol levels. So only about a third comes from our typical food patterns, so what we eat. 2/3 of it, though, is actually made by our body cells. So it's not actually, the majority doesn't even come from our diet. It's what we are making within our cells. So the typical daily consumption's anywhere between 180 to 325 milligrams from animal-derived food products, because again, plants don't make cholesterol, fungi don't make cholesterol, fish. So again, we need to have those animal-derived, so our fish or chickens or cattle, those kind of things. So essentially what happens is if we consume more in our diet, then our liver just makes less. So again, we have a certain amount we need. If it all comes from our diet, then our liver just doesn't make as much. Now the saturated and especially the trans fats, they have the greatest impact on our blood lipids. So that's where, so it's not so much the cholesterol we're consuming, it's the fats. And especially the trans fats are really going to increase the amount of, especially that low LDL that we want to keep lower. So rich sources of cholesterol usually also those sources of saturated fatty acid because they come from animals. So really it's not so much that we're consuming too much cholesterol, it's this, as we're getting the cholesterol, we're also getting all this extra saturated fats. That's the negative player. So our omega-3 fatty acid intake, again, consuming seafood 1 to 2 times a week. And that just helps to make that EPA and DHA to help with body processes, helps keep our heart and our brain healthy, also decreases inflammation and rheumatoid that's associated with rheumatoid arthritis. Now you can't have too much omega-3 that can cause bleeding and even hemorrhagic stroke. So there is a limit to how much should be consumed. And then you'll see a lot of like fish oil that's in capsules because some people don't like fish. So consuming the capsules, and it has about 1 gram of that omega-3 fatty acids from the fish oil. That's about what's recommended every day. So again, eating well for our heart health. So the American Heart recommends, again, trying to have a healthy body weight, keeping up with our lipid profile, so having blood work done to look at our LDL and HDL levels, monitoring blood pressure as well as glucose levels. They do suggest that Mediterranean diet that's more plant-based because it removes a lot of the saturated fatty acids. So most of the protein comes from fish. So that is recommended, especially for those prone to cardiovascular disease. And most of the fat's going to come from olive oil there. And then there is also some vegan diet plans that are available that are very low in fat. Right, so again, just kind of looking at the American Heart Association, some of those recommendations. So, just using the calories that we're taking in to prevent excess. Variety, we'll see that all semester. So variety is the key there. So lots of different fruits and vegetables, different whole grains, our dairies, our different types of protein, nuts, different types of oils. So again, a lot of variety here. And then also eating less of our nutrient poor. So again, those beverages that just have a lot of calories but low nutrients. And then also decreasing the amount of saturated fatty acids, and even more so the trans fats as well as sodium. All right, so a few others here. So just some daily food choices that you could make. Again, variety of fresh frozen fruits and vegetables, fiber-rich whole grains, using poultry and fish without the skin decreases that saturated fatty acid. Again, a variety of fish that have those omega-3 essential fatty acids in them at least twice every week, using fat-free or low-fat dairy, omitting hydrogenated vegetable oils and especially trans fats, limiting saturated and again especially trans fats, replacing those with the unsaturated fatty acids, cutting back on those added sugars from our beverages and foods, eating less sodium foods, especially canned vegetables. If you're drinking in moderation, and then also just following those recommendations when you eat out and keeping an eye on those portions. So just some tips here for cutting back on the saturated and the trans. So kind of are eating less over here on the left. Want to eat more on the right. So as far as grains, again, whole grains, brown rice, air popcorn instead of all of the extra butter that's on it. As far as vegetables, the fresh, frozen, baked or steamed, not French fries, not potatoes or put in butter. As far as fruit, not eating pies to get our fruit intake, but again, fresh, frozen, or canned. Instead of the whole milk or ice cream that have a lot of fat, or cheesecakes, switching more to low fat or fat free. As far as proteins, staying away from the ones that have a lot of fat within them. So like the bacon that's marbled, sausage has a lot of extra fat in it. Even organ meat, because it's usually surrounded by fat to protect it. And the egg yolks. Egg yolks have extra fat in them. So again, skinless fish, lean cuts of meat, different beans, peas, or lentils as far as plant-based, eating the egg white or egg substitutes, and then nuts and nut butter. And then as far as the fats, instead of eating the butter, it's better to consume those unsaturated fatty acids in the way of oils. All right, so as far as cardiovascular disease and lipids, so just looking at some of the risk factors and what atherosclerosis is, and then ways to help prevent it. So cardiovascular disease is the leading cause of death in North America. About 840,000 people die every year. So it's estimated about one person dies about every 40 seconds from a heart attack. Women generally lag about 10 years of age behind men in developing it. So it's not that they don't, it just takes them a little longer. So the development of it, so it increases your chances if we damage our blood vessels. That can occur from smoking, also having high blood sugar in the form of diabetes, having high blood pressure, and some different infections can destroy or damage our blood vessels. So white blood cells that are part of our immune system, that they can be damaged whenever that LDL is oxidized. So again, decreasing our LDLs, our low density lipoproteins. So they can then form that atherosclerotic plaques. So again, these white blood cells, that's where that damage is happening. All right, so those plaques then increase in size. They also become hardened or stiffened, and that causes our blood vessels to be more narrow and less flexible. So as we think about like a pipe, if we are coated with a bunch of plaques, it's a smaller hole for them and it puts more pressure on the blood moving through them. Also, blood clots or rupturing of the plaque can block the vessels, and that can lead to a myocardial infarction, which is a heart attack. And that's actually where the heart muscle actually dies. Or we can have a cerebrovascular accident or a stroke. And that's where the brain isn't getting enough blood due to a blood clot. So it's actually destroying parts of the brain tissue. So again, just how this builds up. So again, this is a nice healthy blood vessel here, but then we get some of these plaques that are forming. That LDL is storing the cholesterol here on the inner lining of the blood vessel. That just keeps building and building into those plaques until now there's so little, this plaque's so big, there's so little room for the blood to get through, and it creates this high blood pressure and can even become completely blocked. So some different risk factors. So some that you just can't change. You can't change your age. So as we get older, it just increases our risk because our blood vessels have just had more chance to store cholesterol. Again, our gender, so males are at higher risk than females. And definitely there's hereditary, so high blood pressure if it runs in a family. Again, you can't change your genetics. Now, some things that we can modify, so smoking increases cardiovascular disease, so not smoking. Keeping an eye on high blood pressure, and that can either come through diet and exercise or medication if it can't be controlled in those ways. Decreasing high cholesterol so that it's not setting on the inside of our blood vessels. Having more of an active lifestyle. So if we're just sitting around, again, that decreases the insulin output, which decreases the lipoprotein synthesis. And so there's not as many lipoproteins to move the fat and the cholesterol out of the way. Excess body fat can lead to that. So again, decreasing our fat content and using up the calories that we're taking in. And then also diabetes. So it essentially guarantees cardiovascular disease because insulin increases cholesterol synthesis in the liver. So again, even if our diet doesn't have cholesterol, the diabetes from too much sugar causes our body to make an increased amount of cholesterol. So some warning signs of a heart attack. So in men, kind of this crushing pain or squeezing pressure on the chest. Women, kind of more dizzy or fainting, really tired, kind of pressure, fullness, burning in the chest or abdomen, and then more of the indigestion, so just stomach kind of upset. Now both of them, pain in the jaw and the neck is somewhat common. Their heartbeats are regular, short on breath, they have a pain in their back, or they have nausea or vomiting. So some plant sterols for cardiovascular disease. So these are clinically shown to reduce the bad or LDL cholesterol, still provides some of the sterols that we need to make our hormones and such. But again, it decreases the absorption of cholesterol and lowers the amount returning to the liver. The liver takes up more cholesterol and makes that bile acid to help to break it down or digest it. So some of the products that contain plant sterols, they kind of have the following health claims. So foods containing at least 0.4 grams of plant sterols eaten twice a day with meals, or a total daily intake of double that, so 0.8 grams, as long as decreasing saturated fatty acids and cholesterol in our meals has been shown to decrease the risk of heart disease. Right, so then there are also some medications if this can't be controlled by diet and exercise. So to lower LDL, there are statin drugs. This decreases the cholesterol production. Again, most of the cholesterol we have is what our body makes for us. So decreasing that. A group of drugs called resins. They bind to the bile acids to help dissolve them better. And then also absorption inhibitors, so preventing that cholesterol from being absorbed. And then also to help lower blood triglycerides instead of the cholesterol is just reducing their synthesis by a group of drugs called fibrates. So as far as building a heart healthy meal, I'm using my plate. So some things, again, choose whole grains. They have more fiber, less added sugar in them. Choosing low fat or fat-free dairy products. Also having a variety of fruits and vegetables to pick from. Again, they have the fiber. They have lots of different vitamins in them as well, but then also cooking them in heart healthy oils instead of butter or margarine, and using the fresh or frozen to limit the sodium that's in them. And then as far as our proteins, so choosing lean options and then substituting plant for animal sources at least several days a week. And it's showing a good portion of seafood, so fish like salmon, for example, that have that essential fatty or omega-3 fatty acid in it, helps decrease inflammation and just promotes better cholesterol levels. Okay, there's also some surgical treatment of cardiovascular disease, so two that are most common, so the PTCA, percutaneous transluminal coronary angioplasty, usually just referred to as angioplasty. This is where they insert a balloon catheter into an artery. Once it's in there, so once that area has a lesion or a blockage, then the balloon is expanded and it just crushes up the plaque that's in the area. The other one is a bypass, fully called a coronary artery bypass graft. So this is relocating a large vein and actually going around or bypassing a vessel that's been blocked. Wrapping up talking about the impacts of our gut microbiota on our heart. So some of them definitely provide benefits. They help break down undigested food that's in our GI tract. They make different proteins and short chain fatty acids that we can use. However, some microbial enzymes have been shown to promote inflammation, altering lipid metabolism, and some are known to have cause an increased risk of cardiovascular disease. So again, as far as thinking about like probiotics or prebiotics, trying to put in good bacteria or good microbes we know that provide benefits to kind of weed out or eliminate these that are making different enzymes that could be potentially harmful.